it up into these pieces.
Right.
And each time you're breaking it up into something you know how to take derivative, like you know how to take the derivative of cotangent, you know how to take the derivative of 2u squared, you know how to take the derivative of pi t plus 2. You just maybe don't know how to do it when it's all meshed together. Now, in terms of like your final answer here, -4 pi, probably the cosecant squared would come first, and then the cotangent pi t plus 2, like that. So 49 is really similar. 50 is really similar. 51's kind of 51, 52 are kind of new. So do you want us to do another one in that grouping?
No, that's okay. We can go to the next section. So now we can start on the ones that I sent you yesterday.
Okay.
We could start at number 5, I believe. Yeah, number 5.
Okay, so these are totally new. These are implicit derivatives. And what's challenging for students in general here is that they don't recognize that y is still a function of x. Okay, but x is not. X is the independent variable, but y is still a function of x. So the way sort of the mechanics of this, so you take the derivatives of anything with x or constants the way you normally do. No big deal, just same old, same old. So derivative of x squared is 2x. When you have a y like this, your y squared, you treat it like it's x. So what would the derivative be if it was x squared? Well, it would be 2x, or in this case, 2y. But because y is a function of x, and this is like the chain rule, the derivative of y is dy dx. So the shortcut here is to just say, whenever you have a y, you're going to have a dy dx equals 0 like that.
Okay, so we just completely get rid of the 9 and just set it to 0 then?
Well, the derivative of 9 is 0.
Oh,
You're taking a derivative of all this, the whole
right,
thing.
right.
But the
Okay,
derivative of, the derivative of x squared is normal to x, derivative of 9 is 0, but the y squared is, you treat it like an x,
yeah,
and then you pair it with a dy dx.
okay.
And now you need to solve for y. So this is now algebra. There's no calculus left. You subtract 2x, 2y dy dx equals -2x, and then you divide by 2y. Minus x over y, like that. Any questions on that?
Nope.
All right. So the solving for sorry, dy dx, not y. The solving for that could involve some factoring, could involve moving stuff around, factoring out. Just depends on the complexity. So 6, 7, and 8 are all the same. They're just variations on 5. 9 is kind of the first different one. That's the one you'll see on your test. 9. 10's pretty complicated, so on, but this is the idea.
Okay, so can we do 9 and 10 then?
Sure. All right, so derivative of x cubed is 3x squared. Now, the derivative of xy, the derivative of this is, so this is where you really have to be careful, or not, you have to be really solid on your product rule derivative. Like, and like maybe by now you know that's f prime g plus fg prime, but like what does that really mean? It means you take the derivative of the first. So the derivative of x is 1. You keep the second, that's y plus. You keep the first x, the derivative of the second is 1 dy dx. Again, you treat y as if it's an x when you're taking derivatives, that you know how to take the derivative, and then you always append a little dy dx there. Plus, so now we're up to the plus here. Derivative of y squared, you treat it like it's x squared, that's 2y, but you always pair it with the dy dx equals 0.
So anytime there's a y now, we pair it with a dy dx.
When you take its derivative.
Okay.
Okay. Now some instructors, and this is actually what I do, I don't use dy dx, so you should know about this notation. Some instructors just use a y prime like that. You got to make it, or y apostrophe, you got to make it really look distinctive so it doesn't match up with like a y to the power of 1. Mostly it's just because you get lazy, you don't want to write all this stuff, but keep in mind you might see that in the videos. So from here you have to solve for dy dx. So 3x squared minus y minus x dy dx plus 2y dy dx equals 0. So this is where it's like, people go through college algebra, pre-calculus, and they really don't have a solid understanding of how to simplify things. Like this should be, I don't want to say easy, but there shouldn't be any concern about how to solve it from here. You move the non dy dx terms to the other side. So you're going to add y, subtract 3x squared, subtract 3x squared. Okay. And then I'm just going to rearrange this a little bit. So it's 2y dy dx minus x dy dx on the left equals y minus 3x squared. Then you factor out a dy dx from both. 2y minus x equals y minus 3x squared. Divide by 2y minus x, 2y minus x, dy dx equals y minus 3x squared over 2y minus, like that. So take a look at that. Let me know if there's any questions, anything that's unclear. And I want to make some more comments about how you might see this on your test or quiz.
No, that makes sense. Makes sense.
So now this is where we have issues with like the multiple choice. So you can, there's like the way this could work is you could factor out a negative from the bottom,
Mhm.
and then it would be x minus 2y on the bottom, but then that negative would go to the top and it would be 3x squared minus y. And these are the same. So it really depends on how you or the instructor factors out stuff.
Okay.
So just be really careful, because you might look at your answer right,
Mhm.
and it really just is written differently.
Okay.
I need to step away for like a minute. Could you maybe just try 10 and I'll be right back to help you work through it. All right, I know that was probably more than a minute, but how are you doing on number 10 here?
I think I simplified it a little more.
Okay. So I mean, appreciate you trying it out here. And the first one, it's another product rule. So it's 2x, y. So, and that, you can do product rule a couple of different ways. Like you can do fg prime plus f prime g. This depends. Like, I mean, so that's where all these variations in the answers can come in. You got to make sure you do both. Okay, so it's x squared times 1 dy dx plus, now we're looking at the second one here, 2y dy dx times x plus y squared, okay, times 1 equals 0. Does this look similar to what you have?
Yeah.
Okay. So again, you move the non dy dx terms to the other side. So it's going to be x squared dy dx on the left plus 2y dy dx on the right with the x. So I'm going to actually move that in front, 2xy equals minus 2xy because we're subtracting that from both sides, minus y squared because we're subtracting that from both sides. Okay, and then you factor out the dy dx, dy dx x squared plus 2xy equals minus 2xy minus y squared. And then you divide. So dy dx equals minus 2xy minus y squared over x squared plus 2xy, like that. And again, like that negative could come out in front. Like you could factor a negative out of both. So it could look like this, negative 2xy plus y squared over x squared plus 2xy. It could be in different orders, meaning like top could be can flip switched, bottom could be switched. It's kind of a headache to so one of the things that they could do, and we'll probably see that in an upcoming problem, is that they will often ask you to evaluate the derivative at a point, and then it doesn't matter how you write it because you're just getting a numerical value as the output.
Okay. Okay. Let's see. We do number 19.
Sure. This is y equals sine xy. Yeah, so the again it's if you can just sort of like you got to be able to like on the left there's a y, so I'm gonna take a derivative of y. On the right, you look at what is the outside function, which is sine. You start from there. You have to know these derivative rules to be able to do this. And I would dare I say we've maybe not done enough practice to be ready for this problem, but we certainly try here. The derivative of y is dy dx. Okay, it's one dy dx. Derivative of y is 1 equals that. Now on the right here, it's really kind of this like sine u thing again, where u is really xy like that. So the derivative of sine is cosine u prime, which means you need a u prime over here on the right. Well, how do you take the derivative of xy? That's my question to you. What do we do? How do we find the derivative of x times y in this case?
Don't we use the f prime g?
Yes. So will you attempt to give me the derivative of u here?
Yeah. G plus f g prime. Is it 1y plus x dx?
Okay, so you take the derivative of the first, which is 1, keep the second, plus keep the first derivative of the second, yes. And so what some students do is they put this on a reference sheet so that
Yeah.
they don't accidentally do it wrong. It's something to. So your derivative here is cosine u, which is xy, and then your u prime is the y plus x dy dx. And yes, it needs to all be in parentheses because the u prime is multiplying the whole thing like that there. So you still have to solve for dy dx. All right. So on the right here, you have to distribute in. So this becomes y cosine xy, and there's generally a preference to put the y's and the other stuff in front, plus x dy dx cosine xy dy dx, like that. Okay, and then we need to get everything on one side. So I'm going to subtract all of this from both sides. So we've got dy dx minus x dy dx cosine xy equals y cosine xy. And then you factor out the dy dx on the left. 1 minus x cosine xy equals y cosine xy. And then you subtract that or divide that out here to get this. I'm going to just step away for 30 seconds. I'll be right back. All right, I am back. Any questions on that or any thoughts?
Nope.
Okay. Okay, where should we go from here?
Twenty. 23.
23. All right. All right, so it says first to find two explicit functions. Find two explicit functions by solving for y in terms of x. So what they're basically saying here is to solve for y. So to do that, obviously move the x squared over. 16y squared equals 16 plus x squared. Divide by 16. And then this is where you get the two explicit functions. You take a square root of both sides, and you get y equals plus or minus square root of 16 plus x squared over 16. And then you can take the square root of the top and the bottom. So yes, you could write it like this, plus or minus square root 16 plus x squared. Square root of 16 on the bottom is 4, and write 1/4 like that. So now they want you to differentiate the explicit function. So your derivative, you just write y prime or dy dx like we've always done. And then this is kind of a u substitution, or I'm sorry, an implicit, sorry, a chain rule derivative. So it's let me rewrite it first. y equals plus or minus 1/4 square root of u, and u is 16 plus x squared, like that. So now you know how to take the derivative of this on the right. You could rewrite it as u to the 1/2 power. And then this is just a power derivative. So you're bringing the 1/2 down, plus or minus. So it's 1/8, 1/2, 1/4 times 1/2 is 1/8 times u to the minus 1/2 times u prime. So we need the u prime over here. So what is the derivative of this here on the right?
It's just 2, right?
2x.
That's,
2x.
yeah.
Yeah. So that comes down as part of this. So your derivative is plus or minus 1/8 16 plus x squared to the minus 1/2 power times 2x, like that. So that's part C, where it says to differentiate the explicit functions. So the only, like, there are two, one's positive, one's negative. I just was including that the whole time. So it's
Yeah.
really, you know, that positive one, that negative. Now, in terms of how this could be written, it would be 2x over 8 square root of 16 plus x squared, still with the plus or minus. And then the 2 and the 8 cancel, so you get x over 4 square root 16 plus x squared plus or minus. And that's how you might see it written.
So how did your 1/4 change into 1/8?
Where is that?
It's up at the top.
When you take the power rule derivative, so that 1/2 comes down.
Oh, okay, yeah.
It's
Okay,
1/2 times 1/4,
yeah,
like that.
okay.
All right, now we have to go back to the original and do it the way we were doing before. So we take a derivative implicitly. So we treat y like an x. So 16 y squared is really like 16x squared. That's 32y dy dx minus 2x equals 0. So this is actually a lot easier as is. So now we're going to add the 2x to the other side. So you get 32y dy dx equals 2x. Divide by 32y. So dy dx equals x over 16y, like that. And so it says that it's equivalent. Well, I mean, it kind of is. I mean, it is, but you'd have to substitute in for y and see that you'd have to substitute like this line back here.
Oh, so we're just showing proof that it could be similar or that it's the same.
Yeah, I guess. I mean, you're not going to get anything like this test, but you'd have to actually take that y and put it back in. But you can kind of see, I mean, there's an x there.
Yeah.
The y is a square root in it. 1/4 of 16 is 4. There is a plus or minus. Like it will work, but I mean, you're not going to be doing this in the test. So sorry
Right.
for scrolling, but this would go in here.
Yeah.
And then you would see that it works.
Mm. We
Give me
do
just a
number.
moment.
Oh, no,
Yeah.
you're-
What's next?
Number 25.
25. Okay. Yeah, so this is This is a good exam question. They want you to find the slope of the graph at the indicated point. All right, so sometimes they only give you the X value. All right. So let's just imagine you didn't know the Y value at the moment. You'd put that X value in, and you do have to solve for Y. So you divide by -6 and Y ends up being -1. Now, I know they give it to you, but keep in mind, sometimes they don't. And then students are like, wait, how do I do this? So what I'd like you to do now is take the derivative of the left side for me, please. That's the one you're going to see over and over again in this course.
Take the derivative of xy.
Yeah, like we talked about.
Same. It's 1y plus x times 1 dy dx.
You say 1y plus x dy dx.
Yes.
Okay, equals 0.
Right.
Because the derivative of 6 is 0.
Yeah.
Okay. So now you got to solve for dy dx. So you're going to subtract y from both sides. X dy dx equals -y, and you divide by x. So dy dx is -y over x. And that's where you need your ordered pair. You need this original point here, the -6, -1. And you're putting that in. So it's -1 over -6 is 1 over -6, or -1 1/6, like that.
Right. Okay.
So that's it. I mean, that's your answer. Your answer is the slope is -1/6.
Can we do 28?
Oh boy. Yeah, 28's a big one. I mean, this is where if you know calculus, if you know to do on this course, yeah, this is a type problem. You got to be like, all right, no big deal. I'm going to work this out. So on the left, the derivative on the left is 12y squared dy dx, like that.
Right.
On the right, it's product rule. I'm sorry, quotient rule. So you have to say, okay, f is x squared minus 36, f over g. G is x cubed plus 36. Can you give me f prime and g prime, please?
F and g prime.
The derivative at the top, the derivative at the bottom.
F is just 2x, or f prime is just 2x, and then
Okay.
g prime is 3x squared.
Okay. So now that the derivative of f prime over g is g f prime minus f g prime over g squared, which is x cubed plus 36 times 2x minus x squared minus 36 times 3x squared, all over x cubed plus 36 squared, like that. You know, and we talked about like when you would simplify. You probably would not simplify this quite yet.
Yeah.
Now on the left here, you're going to multiply by This is, I mean, this is preferred here. If you multiply both sides by 1 over 12y squared like that,
Mhm.
that kind of is better than like dividing because you get everything kind of in the right spot to be able to evaluate. So it's dy dx equals, I have the benefit of copy and paste here, but oops, of course, I fumble it up. All right, let me try this again. Fingers are not working. All right. Copy. And then you put the 12y squared down here on the bottom. And now you put your 6 comma 0 in. Now this is, you really want to kind of look ahead because the fact that y is 0 right here means that the bottom is 0.
Right.
And that means that this is undefined. That means there's a vertical tangent.
Okay.
Now, if it was like, 1 or -1 or something, well, then you would have to put all these numbers in, and that's like we did in the last problem.
Right.
So you can see how this lends itself really well to multiple choice, what's the
Yeah.
derivative of the point? It's 0, it's undefined, it's 1, it's -1, it's, they're,
Yeah. And then we have like these famous curves that he wanted us to look at. Number 33.
yeah, it's just a really complicated way of saying like, hey, you need to, um, take the derivative of this thing on the left here. So one of the things you could do, you have a choice here. You can either multiply the y in and make this squared y plus 4y equals 8. That's one way to do it. Or you can just treat it as its product rule, where, this is f and this is g, like that.
Okay.
So what do you want to do here? Do you want to treat it as product rule, or do you want to do it like the way it is on the left, which is still product rule? Then it's not.
Let's do the product rule.
Okay, so why don't, I'm sorry, this is a 4 here, not a y. Why don't you give that a try? I mean, you're gonna have to do this on your own. You've done a number of examples. Give that a try and let me know what you come up with.
So isn't it just, oh, wait. It's 2x. Isn't it just 2x y and then
Right, so that's the derivative of the first times the second. Now you have to keep the first and take the derivative of the second.
So x squared plus 4 and 1
dy dx
y dx. Okay.
equals 0. Okay. All right, so now I'd like you to try solving this for dy dx, please.
Negative 2x minus y over x squared plus y.
Hopefully something like that, minus 2xy or x squared plus y. I think that's what I heard. X squared plus 4. Sorry, my handwriting is so poor. And then you put x equals 2, y equals 1 in. I would recommend like showing it, go back to like the first time you learned how to substitute in numbers, because it's so easy to just make a small error. So this is -4 on top. 2 squared is 4 plus 4 is 8. It's -1/2 like that.
Okay. And then do we just do that for like all the curves?
Yeah, exactly. I mean, there's nothing special about them other than, I mean, they have names, but they're just like, that's the name of the curve. You, they, you do the same thing. You just find derivatives. The circle ones, that's a pretty common one to get on a test. You will get one implicit derivative on the test. This test is all about taking derivatives. It's all about being able to see something, take its derivative, maybe evaluate it, something like that.
Okay, can we do 49 as the last one? It's like taking the second derivative.
Maybe we'll see how long it is here. These are really, that's not too bad. All right. Yeah, so I actually don't think we're having time, but we'll see what we can do. So the derivative here is 2x plus 2y dy dx equals 4, or equals 0, sorry. And then what you really want to do is actually take the derivative again of this thing that you have right here. This is where it gets complicated, because you're taking the derivative of 2x, that's fine, that's 2. The one in the middle here is product rule. So it's derivative of the first, which is 2 dy dx, keep the second dy dx, plus keep the first 2y, derivative of the second is dy dx, or d squared y dx squared equals 0.
Okay.
And that's the part that I think is probably unclear. We might want to just pick this up next time to give more
Okay.
explanation.
That's
But
fine.
that is kind of, and then so what you end up doing is you end up solving for dy dx. I'm sorry, you end up solving this for d squared y dx squared, and then you substitute back in whatever dx dy is. But let's just stop here. There's only so much math you can do in a day.